Hey everyone, so in the world of breath science, just last month there has been a new paper. Researchers out of University of California and Harvard University have found some groundbreaking science. Now we're going to delve into this in a moment, but we need to really understand and lay the scene before we go into it, because we're talking about brain circuits, and this one was something that was hidden, and maybe now we are starting to look into breathing very differently. So traditionally, we have in a part of our brainstem, which is the kind of primitive part of our brain where our instincts lie and our respiratory control and our heart rate control lays. In the medulla oblongata at the bottom, we have rate control, essentially. It's where the pattern generators are firing information from. Above that, we have the pons group, which is controlling the depth of our breathing and the amount of drive that we have, the inspiratory drive, which is more so force and flow. But we've always had this conscious control over our breathing, this cortical kind of area where I can manipulate and change my breathing for a long period of time. And majority of our conversations around breath is to balance out gases for basically keeping pH into a normal range so that we remain alive. However, a lot of people don't really think of breathing as the rhythm and the behavior of our breathing, because our central nervous system, our peripheral nervous system are basically in a predictive mode. They're trying to predict based off our senses, interpretation, and memory to how to respond. Now, this particular paper was very interesting because it looked at a brain circuit that can kind of control our breathing with particular behaviors, such as drinking, laughing, speaking. These are all behaviors that we do that we have to manage our breathing behind. And this circuit itself looks more so as if it was both under voluntary and under autonomic control. Now, traditionally, when we slow our breathing down, we know that that has an impact on our emotions. So there are breathing patterns that are related to our emotions, such as anger, care, lust, fear, motivation. They all have very slightly breathing patterns in terms of their depth and their frequency, depending on the arousal and the valence of the emotion that we're experiencing. When it comes to consciously slowing our breathing down, it's always been believed that it's just directly from the prefrontal cortex straight to the diaphragm, essentially. However, this brain circuit is a brain circuit that goes from a part of our brain called the dorsal anterior cingulate cortex, which is in the prefrontal cortex, but then it goes into the pons group. So it's linked to these autonomic regulators as well, which is suggested that it is involved behaviorally. And what this research was, it was looking at mice. So first of all, there's two things here. It's in mice and it's in preprint. Now, preprint usually means that, okay, the researchers are trying to get the information out there so it gets eyes on it, so people start talking about it early, so that when it's published, it gets more citations. This is sometimes done by breakthrough papers in Nature to ensure that people get a lot of eyes on it and to create some, scientific marketing around a new theory. So what's this new theory? Well, the mice, what they were shown is that when the mice went through into fearful situations and they created what we call avoidance behaviors, freezing up, it's part of this brain, this DACCC pons group circuit kind of reduced in activity. However, when the mice actually went to escape behaviors and they kind of left and were safe again, there was an increase in this activity in the brain. And that was directly related to a decrease in respiratory drive and a decrease in respiratory rate. So what the researchers are suggesting is that actually this new brain circuit is maybe involved in calming of emotions and slowing the breath down. And that voluntary control of our breathing, we know, has a relaxing element to it when we slow the breath down. And perhaps it's this brain circuit that is actually involved in this. That's what the suggestion is around. And obviously it's very speculative right now. However, this gives a bit of weight also to what we maybe see in things like nasal breathing adaptation training. If an individual is able to relax and are able to stay calm and gradually increase their ability to use their nose during exercise, perhaps we are seeing a shift in the air hunger being processed by the same part of our brain, the anterior cortex, which is related to emotion. And rather than that information going down to the amygdala to cause this kind of fear response of air hunger, when people are adapt, maybe it's going down to this pons group and we're actually seeing a relaxation element, because that what seems to what happen when people adapt to nasal breathing is they feel as if they're more calm, more relaxed. There's potentially more sympathetic nervous activity. And I think, again, very speculative, putting pieces together, that could be the thing. So researchers found a new brain circuit going from the DACC down to the pons, which is basically suggesting that maybe there's a voluntary and an involuntary circuit that's around behaviors, particularly behaviors coordinating our breathing with things like drinking, but also down to slowing our breathing down, the relation that has with our emotions. This is at the very early. The next steps are going to be to see whether this is also a part in a human. And then obviously the next step would be then looking at changes in the brain, potentially under things like air hunger, and seeing whether this circuit is active or deactivated in those periods as well. So the research is really at the very beginning, but it's going to allow us to start to understand behaviors and breathing a lot more, hopefully. So I hope you enjoyed this episode. Obviously, I'll pop all the references below. And if you haven't already signed up to the School of Breath Science, www.schoolofbreathscience.com. You're going to get a lot more of this, newsletters, exclusive offers, etc., etc. And if you join, drop me an email, ask me some questions, and let's make some more content. Thank you.